The negative effect of aviation on the environment is evident, and although many improvements and innovations help to reduce the impact of this negative effect, the industry is still lagging. As studies suggest, the pace at which the industry is progressing on mitigating the greenhouse gas emissions is considered to be slow and still behind the set targets. Bold and disruptive concepts should be embraced and evaluated. Such ideas and concepts may carry the solution for a greener and environment-friendly aviation. Here is one such concept, and as always, new ideas will attract spontaneous objections. Therefore, and for a while, please put such objections aside and follow on with an open mind. Let us get started. This concept is all about controlling the airflow around the aircraft and using it to reduce various drag forms, in addition to gaining other benefits like better crosswind handling, shorter takeoff and landing runs, and much more. We agree that the concept of a greener aircraft boils down to one that experiences less drag. Looking at the frontal view of a typical aircraft, we see 1. The fuselage, 2. The leading edges of the wings and the stabilizers, and 3. The engines. The first two displace the air and therefore generate various types of drag. But the engines, on the other hand, consume the air at the front and yield a low, negative pressure zone and therefore does not generate drag. Now imagine if the low pressure zone is shifted, for example to the front of the fuselage. What will happen? Well, we'll have an aircraft continuously moving in a low pressure zone. Now compare this with the mainstream air displacement approach. Can you see the difference? The concept uses an air intake structure in the form of an outer, rugged, and lightweight shell, and a group of airflow control additions to restrict and control the engine's air intake from specific sections of the body of the aircraft. This will mitigate the pressure drag and allow for unprecedented flexibility in controlling the aircraft. The outer skin is fixed on the uniquely shaped fuselage. The two complement each other to define a space between them. The outer skin has openings and perforations at the nose to reduce pressure drag, the top to reduce induced drag, and the empennage to enable a pressure gradient alternative to air deflecting control surfaces. This video is only an introduction to the concept. You are invited to visit the dedicated website, airplane.greentransport.tech.